Hello, so today I'm going to show you how to do a differential equation, and we'll start with this one example, just a nice short video just to show you how it works. So let me start by writing the equation, which is here. So that is dy by dx equal to x times by exponential of x. Okay, so there is a little trick here when you're dealing with differential equations, and there's a certain form that you need to stick to when you're trying to solve differential equations. So I'll write it as follows. So that would be, you would like a function of x multiplied by the derivative of x, and then you would like a function of y with the derivative of y. Now essentially what you should notice here is that everything on the left side is to do with x and everything on the right side is to do with y. So that's how we would like to split it up. We call this separating the variables. Now what you might notice here is that you just have an x here and an x there, and you might be wondering, well, there isn't any y's here, and you'd be absolutely right. Now sometimes this function of y is not always a function of y. Sometimes it might just be a constant. For example, what we mean by a constant is a number like 4 or 9, for example. So these numbers are constant because the number 4 doesn't change, it just has a constant set value. It doesn't depend on anything. Okay? So you'll see how this works here. So if I look at my differential equation, you see that I have dy in the numerator on this side, and I have dx in the denominator. The first thing I will do is I will move the dx to the right side, meaning I'm going to multiply both sides of this by dx. Let me write that. So LHS meaning left hand side and the right hand side by dx. Okay, so what happens here, if you think about it, is you've got dy over dx times by dx. That will just leave you with dy. Then we have x multiplied by e to the power of x. And now what you should find is that dx is now on the right side here. Okay. Notice dy is on its own at the minute. What we could introduce here to make it look a little bit better is in front of this dy we essentially have a 1. The number 1. So you might think there's nothing there. That's not true. If there was a 0 there, then this left hand side would say 0. So actually there's the number 1 in front of the dy. Just like if you wrote x, you don't write 1x usually, you just write x. Effectively there's also a 1 here if you think about it. Okay. So in this particular form is actually what I needed. What you should notice here is that this is my function of y, and that's dy next to it. And on the other side we have the function of x next to the derivative of x. So it's in the form that we required at the top here. So now it's in this form, we can actually deal with it. In fact, I'll actually use a different page for this, so I'm going to take this onto a different page. Now it's in this form that we require, we can simply integrate both sides. Remember, when we have an equal sign, we can do whatever we want to the left and the right, as long as we're consistent and we do the same thing to both. So I'm going to attach an integral symbol onto the left and the right. So you can see the left needs to be integrated with respect to y. Now it's just the constant 1, so this should just give you y. Now you might be wondering why I've not wrote plus c, because there's no limits on it. Well, we only need one constant, because if there's a constant on the left and the right, which might just be a number like 4 for example, then you can actually just combine that into one constant on one side of the equation, and I prefer to put that onto the right side. So I write that after the right integral. Next thing we need to do is we need to use integration by parts in order to deal with this product that we have here. Yeah, so whenever we're integrating products, it must be done by parts. And let's just write that formula just in case anyone's forgot. So this is the way I prefer to write it. If we had a function u and a function v dash like that with respect to x, with these being multiplied, the answer would be uv, take away the integral of v multiplied by u dash with respect to x. So here we just need to make a note of what's what. So the u in this case would be the x. Now just bear in mind, when you're using by parts, most of the time you would set u to be x, or if you had, for example, x squared, that would be what you set u as. The reason for that is because when it's differentiated, it goes to 1, which simplifies the integral. Of course, if you use x squared, it won't go to 1, it will go to 2x. But once you then use by parts for a second time round, it will then simplify down to a constant, making it simpler. But for this particular one, we only need to use by parts once. So here we go. So let's define our u. Remember, u is the one that's to be differentiated, and this in this case will be x. The one that's to be integrated will be your v dash. So whenever I write a dash on a variable like that, it indicates that it's the differential. Okay. And so we need to compute u dash and v. So to get u dash, we differentiate x, which just gives us 1, as we said earlier, given as a constant, which is nice. So then when we get to this part here, you'll see that this will just be a 1, meaning that integral has been simplified, as it will then just be v. So to get v, we need to integrate v dash. Now whenever you integrate an exponential, especially e to the power of x, it integrates back to itself, which is very nice. Okay, if we didn't choose x to be u, if we did it the other way around, we made v dash the x, then you'd be integrating the x, which would increase the power on x, and therefore it wouldn't go back to a constant. So that's the wrong way of doing it. So in this case, you let x be the one to be differentiated. So using what we have here, let's put that into our formula. We only need to do this part here, since this part will be what we have there. Okay, so we just need to work this out. So let me follow down just to make sure we're in line still. So we did have a y here, that's fine. And then we perform this integral. So we have uv first, which will be x is u and v is e to the x. And then we have a subtraction symbol followed by the integral, which is now vu dash. Now remember, u dash is only 1 and v is e to the power of x. So doing it properly, I'll be writing it like that, but just bear in mind 1 times e to the x just gives you e to the x. So this isn't required. Okay, now this is nice because we've already done this integration here, as you can see. So the answer will come out again the same as e to the x. And so finally y equals x e to the x subtract e to the x. And that this final point is where we add the constant on the end. Okay. Just going back to the start of the question, you should see that you were given a value of y and a value of x. The reason they do that is because this will allow you to calculate the constant. So these two here giving you the c that we require. So let's have a go at that now. So finally, last thing to do is to just substitute in that we have x and y both being 0. And so this will give us 0 for y, 0 for that x there. We've got e to the power of 0 minus e to the power of 0 plus c. Let's simplify. So we still have a 0 this side. 0 times anything is just 0, so this one here goes to nothing. Then we have take away e to the power of 0. Anything to the power of 0 is 1. So this actually will just be minus 1 plus c. If I then take this minus 1 to the other side, that will then finally give us that c equals 1. And if I then put that back here where the c is, that will give me my final solution, which I'll just squeeze here. So this is what we call a particular solution. And this one here we would refer to as a general solution. And that's it, complete. So the final answer is the particular solution as they gave you the value of y and x. So you give it with the plus c defined.